Hello everyone, welcome back to Chemistry 24/7 series. In this series, we have been exploring solution for previous year exam papers. If you are new to this channel, don't forget to subscribe. Let's dive what's today's problem. This is the problem from University of Hyderabad, PhD entrance exam 2019. According to this problem, this substrate initially react with LDA under minus 78 degrees Celsius, which produce product X. This product X further react with benzaldehyde that produce product Y. So here you see there are four options. Let's find out together which one is the correct option for this question. So here you see the first reaction condition is LDA under minus 78 degrees Celsius. So LDA we have already discussed in our channel. If you missed to watch that series, don't worry, you can find the link from our description box. LDA is one of the non-nucleophilic sterically hindered strong base which readily abstract the proton from less hindered side. Let's come to our substrate. So here you see our substrate have two acidic proton. Therefore, when you use LDA, which readily takes one of the proton, which produce corresponding inlet ion. However, closely look, this substrate has one methyl substituent. That means that when you use LDA, there is a possibility to get the mixture of E inlet ion or Z inlet ion. Okay, then how we can find which inlet ion preferably form in this reaction? So now you consider this reaction. So this example. So X means some substituent as well as R also some of the substituents. So when you use LDA like bases, so we already know that LDA could take the proton through the six-membered cyclic transition state. We already know that this one. So that six-membered cyclic transition state, there are the two six-membered cyclic transition state would be possible. So here you see the first six-membered chair-like transition state. So if you have larger R group or larger L group, so this particular cyclic transition state experience with heavy 1,3 diaxial interaction. So if it heavy 1,3 diaxial interaction, this equilibrium shifted towards the formation of this six-membered chair-like transition state. However, this six-membered chair-like transition state also experience with A12 strain. This A12 strain arises because of the larger X group as well as the larger R group. So if your substrate follow this transition state resulting that produce Z inlet ion, this Z inlet ion favored by large X group and small L group. So if your substrate follow this transition state resulting that produce E inlet ion, which is favored by small x and large L group. So now you see this table. So here you see R, you just consider as a methyl group. So X means there are variety of the functional groups such as methoxy, ethyl, isopropyl, tertiary butyl like that. So in our case, we have tertiary butyl. So you just imagine that when you put the tertiary butyl, there is a larger bulky group. So that heavily experience with A12 strain resulting that produce this corresponding Z inlet ion. So sometimes we can switch the inlet ion selectivity for especially when you use the mixture of solvents such as THF HMBA, which predominantly produce the Z inlet ion, since this HMBA readily coordinate with lithium cation, so resulting that this reaction undergo by open transition state, which leads to produce corresponding Z inlet ion. Our first reaction condition, which readily produce the Z inlet ion, this Z inlet ion readily react with benzaldehyde in the subsequent step to produce the corresponding Cross-Aldol product. So particularly this step, which undergo by Zimmermann-Troxler model. So this one we can easily explain which aldol product is formed, either syn-aldol or anti-aldol product. So now you consider this Z inlet ion react with benzaldehyde, which readily undergo by this reaction by six-membered chair-like cyclic transition state. So here you see there is a only difference in between these two transition state is how benzaldehyde is approached with Z inlet ion. So here you see here hydrogen is axial, while in this transition state, phenyl is axial. And here phenyl is equatorial, here hydrogen is equatorial. So first now you closely look this transition state, which experience with minimal 1,3 diaxial interaction since here tertiary butyl, while in this case hydrogen. So when you come to this transition state, which experience with heavy 1,3 diaxial interaction. So here you see phenyl also larger group as well as tertiary butyl also larger groups. So based on that, so this transition state is favored. So the favored transition state which readily produce the corresponding syn-aldol product. If it disfavored transition state which produce the minor amount of anti-aldol product. So based on our discussion, we can easily say that the answer A is the correct option for this question. So if you are struggling to understand this type of transition states, so you just remember this only one line. So if you take the Z-enolate ion resulting that produce always syn-aldol product, if you have E-enolate ion which always produce the anti-aldol products. That's it for today's problem. If you enjoyed this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe and click the bell icon to stay updated with our latest videos. And finally, thanks for watching for Chemistry 24 into 7 series where chemistry never sleeps. Bye bye.